Hello viewers, welcome to my channel. I'm Hasham. Last three videos I have explained you about the topic queuing theory. The meaning of the term queuing theory, what are the advantages, limitations, and what are the assumptions and what are the formulas which are used in queuing theory. All these things I have explained. Hope my regular viewers have already watched all the three videos. Be perfect about the concept, then only you can be able to understand the problems. Now I'm going to start the problems on queuing theory. So before starting the problem, I expect my viewers to have a printout of the problems which I have given in the link under my description. Always keep it ready, then only you can be able to understand the explanation of these answers to these problems. Take the screenshot of the first few problems, then I'll explain every problem in detail. Now, see the first problem. A departmental store has a single cashier. During the rush hours, customers arrive at the rate of 20 customers per hour. So this is the arrival rate. In queuing theory, the arrival rate is denoted by lambda. So lambda denotes arrival rate. Here arrival rate is 20 customers per hour. The average number of customers that can be processed by the cashier is 24 per hour. So here we are given the arrival rate and also the service rate. Service rate is denoted by mu. The mu is 24 customers per hour and arrival rate lambda is 20 customers per hour. Assume that the conditions for use of the single channel queuing model apply. Now 5 questions are asked. The first question, what is the probability that the cashier is idle? Second, what is the average number of customers in the queuing system? Third question, what is the average time a customer spends in the system? Fourth question, what is the average number of customers in the queue? And last, fifth question, what is the average time a customer spends in the queue waiting for services? See here, the problems on queuing theory depends on the formula. So you must know the formulas for different cases like LS. LS stands for average number of customers in the system. LQ, average number of customers in the queue. WS, average time a customer spends in the whole system. Then WQ, average time a customer spends waiting in the queue. Right? So these are the different formulas I have already given in the previous video. So if you have not watched the formulas, then go to the playlist of my channel. Select the subject, Operation Research. Select the videos of queuing theory. Watch the first 3 videos. Be perfect about the formulas. Then only you can be able to solve these type of problems. Now, see how we have to proceed. We are given arrival rate, lambda, is equal to 20 customers per hour. Every hour 20 customers on an average arriving and joining the queue. And lambda mu, the service rate is denoted by mu. How many customers will be served, will be processed in 1 hour? So it is given in the problem 24 customers are processed in 1 hour. So we are always given lambda and mu. Now probability that the cashier is idle. The cashier is the server who provides the service. What is the probability that the cashier is idle? When the cashier will be idle? When there are no customers in the whole system. So we need what is the probability of no customers in the whole system. In the previous video I have given the formula PO. PO stands for probability that there are no customers in the whole system. The formula for PO is 1 minus lambda by mu. 1 minus lambda by mu. So 1 minus 20 by 24. 1 minus 0.833. That comes to 0.167. 0.167 is the probability that there are no customers in the whole system. When there are no customers in the whole system, the cashier will remain idle. So 0.167 is the probability that the cashier will remain idle. That's it. Next, average number of customers in the whole system, LS. It is asking you what is the average number of customers in the whole system. The symbol is LS. The formula for LS is lambda divided by mu minus lambda. Always keep a notebook, pen, calculator ready while watching this video. Note down the formulas. Again and again, if you write the formulas, you will be perfect on the formulas. You can easily attempt the problem in examination. So LS stands for average number of customers in the whole system. The formula is lambda divided by mu minus lambda. Lambda is 20, mu is 24. So 20 divided by 24 minus 20, that comes to 5. LS is equal to 5. That means on an average 5 customers are there in the whole system. That is LS. Now third question is average time a customer spends in the system. That is denoted by WS. WS stands for average time a customer spends in the whole system. The formula for WS is 1 divided by mu minus lambda. 1 divided by 24 minus 20. That is 1 by 4. This is time. Time is expressed in terms of hours. Time is expressed in terms of hours, whereas units is measured in terms of customers. So here LS, average number of customers in the whole system. WS, average time a customer spends in the system. So time is measured in terms of hours. So 1 by 4 hour. So if you want in minutes, multiply the hour with 60, because 60 minutes makes 1 hour. So 1 by 4 into 60. 1 by 4 is nothing but 0.25. 1 divided by 4 is 0.25 into 60. You will get 15 minutes. So on an average, a customer spends 15 minutes in the whole system, WS. Next comes average number of customers in the queue. What is the average number of customers in the queue? Here we have calculated the average number of customers in the system. System means queue and also the person who is getting the service. But here average number of customers only in the queue. That is denoted as LQ. LQ is the symbol for average number of customers in the queue. The formula is lambda square divided by mu into mu minus lambda. Note it down immediately. LQ, average number of customers in the queue. Lambda square divided by mu into mu minus lambda. Lambda square, 20 square, divided by 24 into 24 minus 20. So 24 minus 20 is 4 and 20 square is 400. So 400 by 96, 4.17. So average number of customers in the queue is 4.17 customers. Now it looks strange how the customers can be in fraction. That is the limitation of queuing theory. One of the limitation of queuing theory is the units you may get in fraction. In reality, we don't have 4.17 customers. We may have 4 customers or we may have 5 customers. We don't have fractional customers. But here, that is a limitation. So theoretically, the number of customers in the queue is 4.17, whereas number of customers in the whole system is 5. Next, fifth one. Average time a customer spends in the queue. Here we have calculated the average time a customer spends in the whole system. That is WS. Now we are calculating WQ. Average time a customer spends in the queue. The formula for WQ is lambda divided by mu into mu minus lambda. Lambda is 20, mu is 24. So 20 divided by 24 into 24 minus 20. It comes to 20 by 96. It will comes to 0.20833 hour. Because time is measured in terms of hours, right? So if you want to convert the hour into minutes, multiply by 60, you will get 12.5 minutes. So on an average, 12.5 minutes is the average time a customer spends in the queue, and 15 minutes average time the customer spends in the whole system. That's it. First problem I have explained. Now I'm going to start the second problem. Customers arrive at a booking office window. This booking office window is the server where service is provided to customers. The customers arrive at the booking office window being manned by a single individual at the rate of 25 per hour. The arrival rate. Every hour 25 customers are arriving. Then the time required to serve one customer has exponential distribution with a mean of 120 seconds. The one customer is served in 120 seconds. 120 seconds means 2 minutes. 60 seconds, 1 minute. So 120 seconds, 2 minutes. So every 2 minutes, one customer served. Find the average waiting time of a customer. Waiting time means he is waiting in the queue. So we have to find out what is the average time a customer spends in the queue. WQ. That you have to identify. It will not be given in the problem. You must read the problem, understand it. It is asking you average waiting time. Where he waits? In the queue. The WQ we need. So first of all, we want lambda and mu. Lambda arrival rate, mu service rate. The lambda is given in the problem. Arrival rate 25 customers per hour. Every hour 25 customers are arriving. Mu service rate. 120 seconds required to serve one customer. 120 minutes means 2 minutes. So 2 minutes, one customer served. For 60 minutes, because we need per hour. Because here the arrival rate is given per hour. So here service rate also we require per hour. So in 2 minutes, one customer served. In 60 minutes, how many customers will be served? So 60 divided by 2 into 130 customers. Service rate. In 1 hour, 30 customers are served. In 1 hour, 25 customers are arriving. So we got lambda, we got mu. Now we have to find out what is the average waiting time of the customer in the queue, WQ. The formula for WQ is lambda divided by mu into mu minus lambda. Lambda divided by mu into mu minus lambda. That is 25 divided by 30 into 30 minus 25. 30 minus 25 is 5. 5 into 30, 150. 25 by 130. 150, sorry. 25 by 150. You can write 1 divided by 1 by 6. 1 divided by 6. 1 by 6. Or you can write 0.167 hour because we are calculating time. Time is measured in terms of hour. 0.167 hours. I have rounded off. Actually, it is 0.166666 you are getting. I have rounded off to 0.167. So into 60 because we want to convert from hour to minutes. So it comes to 10 minutes. So average time a customer spends in the queue is 10 minutes. Over. Second problem completed. Now third. Customers arrive at sales counter manned by a single person according to Poisson process with a mean rate of 20 per hour. Arrival rate. Always we have to make the assumption that arrivals are following Poisson distribution and service rate is following exponential distribution. That is one of the assumption of queuing model. So here arrivals are 20 customers per hour, lambda 20. The time required to serve a customer has an exponential distribution with a mean of 100 seconds. In 100 seconds, one customer is served. But we want to find out how many customers are served in 1 hour. So how many seconds are there in 1 hour? 1 hour consists of 60 minutes. And every minute consists of 60 seconds. So 60 into 60, 3600 seconds are there in 1 hour. 1 hour consists of 3600 seconds. Now find the average time of the customer. It is not given average time whether in the queue or whether in the system. So we calculate both. So first of all, we write down the information given. Lambda is equal to arrival rate 20 customers per hour. It is directly given in the problem. But service rate is not directly given per hour. It is given for serving one customer. 100 seconds are required. So 100 seconds one customer served. How many seconds are there in 1 hour? 3600 seconds. So for 3600 seconds, how many customers? So 3600 divided by 100 into 1, 36 customers will be served in 1 hour. So we got the service rate. Always we need per hour. For a unit of time, we need the arrival rate, and the same unit of time, we need the service rate. So per hour arrival rate 20, per hour service rate 36. Now it is asking you to calculate the waiting time. Not waiting time, but average time it is saying. So average time in the system and average time in the queue. First we calculate what is the average waiting time of the customer in the queue. Average waiting time of the customer in the queue. The formula WQ, lambda divided by mu into mu minus lambda. 20 divided by 36 into 36 minus 20. 36 minus 20 is 16. So you will get 20 divided by 576. It comes to 0.0347 hour. By applying the values in the formula, we are getting the time in hours. Now, if you want to convert from hour to minutes, multiply by 60. So into 60, 2.08 minutes. So 2.08 minutes is the average waiting time of the customer in the queue. Similarly, what is the average time of the customer in the whole system? WS. The formula is 1 divided by mu minus lambda. 1 divided by mu minus lambda. 1 divided by 36 minus 20. 1 by 16 R. 1 by 16 R. If you want to get it in minutes, so 1 by 16 into 60, you will get 3.75 minutes. That is the average time a customer spends in the whole system. And this is the average time a customer spends in the queue. That's it. 3 problems completed. Now, 4th problem. A repair shop attended by a single machine has an average of 4 customers an hour who bring small appliances for repair. So this is a repair shop, single counter, single channel. Customers are arriving. At what rate? 4 customers are arriving every hour on an average. On an average. So this is the arrival rate. Lambda, 4 customers per hour. The mechanic inspects them for defects and quite often can fix them right away or otherwise render a diagnosis. This takes him 6 minutes. By mistake, it is written as 6 months in the paper. In this question paper, it is given 6 months. Cut off that months, make it minutes. So this mechanic is taking 6 minutes on an average. So every 6 minutes, one customer is served. Every 6 minutes. How many minutes are there in 1 hour? 60 minutes. So in 6 minutes, one customer. In 60 minutes, how many customers? So 60 divided by 6, you will get 10 customers. So service rate, every hour 10 customers are served. Arrival rate, every hour 4 customers are arriving. So we got lambda, we got mu. Arrivals are Poisson and service time has the exponential distribution. You are required to 1, 2, 3, 4. 4 questions are asked. One by one we'll attempt. First one, find the proportion of time during which the shop is empty. First of all, we write down lambda is equal to arrival rate, 4 customers per hour directly given in the problem. But mu, service rate, is not directly given. It is given 6 minutes to serve one customer. So in 6 minutes, one customer, and R consists of 60 minutes. So in 60 minutes, how many customers? 60 by 6 into 1, 10 customers. Service rate is 10 customers. We got both lambda and mu. Now proportion of time when the shop is empty. First of all, remember, when the shop is empty, when there are no customers in the whole system, the shop is empty, then only the server will be idle. So what is the probability that there are no customers in the whole system? I have given one formula. In the last video I have given PO. Probability that there are no customers in the whole system. Here in the first formula also, first problem also I have applied. PO is the probability of no customers in the whole system. The formula for PO is 1 minus lambda by mu. So here 1 minus lambda by mu, 1 minus 4 by 10. 4 by 10 means 0.4. 1 minus 0.4 is 0.6. PO is 0.6. What is PO? Probability of no customers in the whole system. So 0.6 is the probability that the time when the shop is empty. Proportion of time when the shop is completely empty is 0.6. 0.6 is the proportion of time. Now second question. Therefore, proportion of time when the shop is empty is 0.6. Second question. Probability of finding at least one customer in the shop. What is the probability that there should be at least one, minimum one customer in the shop? Easily we can understand. 1 minus probability that there are no customers at all. 1 minus probability that there are no customers. What is the probability of no customers? 0.6. So what is the probability that at least one customer will be there? 1 minus 0.6. 0.4. So 0.4 is the probability that there will be at least one customer in the shop. Here 1 minus probability of no customer, 1 minus PO, 1 minus 0.6, 0.4. That's all. Third question. Average number of customers in the system. LS. Average number of customers in the system. The symbol is LS. LS is equal to lambda divided by mu minus lambda. Already we have applied in the last two problems. Lambda divided by mu minus lambda. That is 4 divided by 10 minus 4, 6. 4 by 6 is 0.67. So average number of customers in the system, LS, is 0.67. Again, a doubt may arise in your minds. How the customer will be in fraction 0.67? The customer may be 1, 2, 3, 4 like that. There cannot be any fraction. But that is a limitation of this queuing theory, that you may get the units even in fraction. Now your doubt is clear. For the sake of theory, you can write the units in fraction also. Now, average time a customer spent including service. Average time a customer spends including service. That means how much time a customer spent in the whole system. The average time a customer spends in the whole system is WS. The formula for WS is 1 divided by mu minus lambda. 1 divided by 10 minus 4. So 1 by 6. So 1 by 6 R, because it is a time. So 1 by 6 R, if you want in minutes, multiply by 60. 1 divided by 6 into 60, you will get 10 minutes. So average time a customer spends in the whole system is 10 minutes. That's all. This is the first video on problems on queuing theory. 4 problems I have explained in detail. If you understand this first video, definitely the coming videos you don't find any difficulty, because the base you got it. So always watch the first video twice, thrice. Be perfect on the formulas. Then the coming videos will be easier for you. So that's why I'm telling you, keep a rhythm on watching one video with another video. Don't join in between, don't leave in between. If you want the perfect knowledge, follow my instructions. Definitely you can get a lot of benefit from these videos. Confidently you can face the examination. You will be equipped with abundant knowledge. Inshallah, we'll continue the next problem in the next video. So if you are satisfied, give a like to the video. Share my channel among your friends, among your group, so that more students can watch the video and enhance the knowledge. Give your comments. Subscribe my channel if you have not yet subscribed, and buy the super thanks which is given below my video. Inshallah, we'll continue the next problem in the next video.